So we have an expression to simplify here, and it could certainly use it. It's got 4 levels. Here's the big dividing line in the center. We've got fractions in the numerator and fractions in the denominator. If we're going to combine these two fractions, then they need to have a common denominator, and the same is true down here. So let's build some denominators first of all. This first fraction contains in the denominator an a, so the second fraction needs a factor of a, and of course that goes in top and bottom. The second fraction needs a 2a plus 1, and again that goes in top and bottom. Downstairs, this 4 is 4 over 1. I did that just because I want it to look like a fraction, and now that it is a fraction, you can say this first fraction has a denominator of a, so the second one needs an a. So let's get that rewritten and see what it looks like now. We have 10 times 2a plus 1. I'll expand that in a moment. We have downstairs a times 2a plus 1 minus 12a over a 2a plus 1, and then downstairs we have 5 over a plus 4a over a. Alright, that was pretty successful. Now, since these fractions now have a common denominator, we can combine them into one fraction, and we can do the same thing down here. So next line, let's see what we've got here. 10 times 2a is 20a, plus 10 times 1 is 10, minus 12a. We have all of that over a 2a plus 1. Big dividing line. And downstairs we have 5 plus 4a all over a. Alright, the point of doing all that is that now we can divide these fractions. This expression means the top thing, 20a, etc., over a times 2a plus 1, over, or divided by, sorry, the bottom fraction, the 5 plus 4a over a. Although, now that I look at it, I actually want to do a little bit more simplification before I get to there. We're going to do top divided by bottom, but first, I can't leave this alone. 20a minus 12a is 8a plus 10 over a 2a plus 1. So we have that divided by, and then we have the, I'm going to write it 4a plus 5 over a, just because I like descending order. Okay, so numerator divided by denominator. Now how do we do this? We don't divide. We multiply and flip. a to a plus 1 times, the second fraction gets turned upside down, a over 4a plus 5. Can we cancel anything? We can cancel the a's. That's easy enough. And there's something else. Do you see it? When I came up with this 8a plus 10, I actually didn't factor this as far as I could, but it can be factored. We can take a 2 out of there, and that leaves us with 4a plus 5 over, we've got our 2a plus 1, we have 1 over 4a plus 5, and of course those 4a plus 5s will drop out. We can divide the top and bottom by that. So in the end, our expression is 2 over 2a plus 1. That's as simple as we can make it. Now, restrictions on the value of a. We have to backtrack here and look at all of the denominators that we've had as we work through this. Every single one of those is forbidden to be a 0. So in the original expression we had an a denominator right there, which would tell us a is not allowed to be 0. we had a 2a plus 1 denominator. So 2a plus 1 cannot equal 0, therefore a cannot equal minus 1/2. Those are a's. We covered that already. 2a plus 1 and a, nothing new here. 5 plus 4a, or here 4a plus 5, you could do it from either of these places. That can't equal 0 either. So 4a plus 5 can't equal 0, therefore a cannot be minus 5/4. And that ought to do it. So 3 non-permissible values and 1 simplified expression.